Yakov Fain. I work for a company, Farata Systems. Actually, this is one of two of our companies. I'm a partner in this company, small one. And we have another startup that is dealing with software for insurance industry. So we develop a product and we have like 200,000 of agents who are using it. This is not to sell you this product, but we are using IoT in that product. That's why I brought it up. So this insurance-based company, we created a site where you can go and find the insurance agent for you. Costs nothing. So, and today I'll explain a use case from that insurance industry when we started to look at Internet of Things and IoT-enabled devices, and we started to see if we can bring it into the workflow of that particular industry. While looking at it, we obviously learned a couple of things, and I want to share with you what I know for now. Basically, the goal was to take a commercial device that you can purchase in stores and use it somehow. And in this demo, in this presentation, I'll do several things. First of all, I'll explain you how we see that how we did it and how you can do it, and even with devices that are not even on the market yet. We are using standard protocols. We are using REST. We are using OAUTH 2 for syndication. So it's nothing specific to a device or to a particular vendor. Open source standard protocols. So I will try to do a demo. I'll show you a device in action, and then I'll explain you like under the hood how this works, because you are technical. This is a technical audience, and I'll explain you some technology under the hood. We used a bunch of different technologies, but in particular I'll talk about REST, and I'll talk about OAuth mainly, maybe some WebSockets as well. So the thing is that IoT became really big. Like a month ago or 2 months ago, I don't know if you caught it, but it's already in the Senate. So usually people start telling you all these Forrester or Gartner millions and billions of devices and how many trillions of dollars you can make. But we know how this works to create a bot and everything. So I was skeptical when I was listening to this like for the last year and a half. But now it's getting even higher, and they want to make sure that the United States of America is the leading country in the IoT space. When it comes to smart devices, smart homes, smart everything, we are the best. So they want to bring it all the way up. Many years ago, in the middle of the 90s, I was working on the application for a client. It was Visual Basic back then, I remember, and we were helping working with these public phones, if you remember the public phones, right? So back then, if you own a pizzeria, for example, you could have rented this phone, and every time somebody makes a call, you make money, commissions. So we wrote a program that was catching the signals from these phones. For example, somebody cut off the receiver, or maybe the coin box is full or half full. So to send the technician to pick up the money or to fix the phone, right? So even back then we were doing telephony, there were sensors, and we were checking every bit on that signal to figure out what's going on. I can tell you that it's not fun, but it was working with sensors. I mean, that stupid protocol, I don't know if anybody would try to do that. It's not something that you learn or enjoy. But I was making money out of it. But technically, it was Internet of Things, in a way. What is a thing? It's a sensor, right? So back then we had these sensors. Now the sensors are much smarter. In July of this year, you will be able, for example, to buy this device. At least I will. This device by that company, it is going to cost $250, and it's like a spectrometer. You can bring it to anything. In this case, they bring it to an apple. You can bring it to medication. If you are brewing a beer, for example, at home, you can check the alcohol content. So you can adjust it the way you like it, basically. So it's a useful thing, right? In my opinion, I'm not brewing the alcohol, but I'm using it. So it is a useful thing. But what I want to say, whenever you see a new device comes up, You go to their website of that particular company, and somewhere down at the bottom you will see a link like API or developer. So they not only release a device, they want to release an API. These guys sell this API, at least they advertise it. So if you want to program and create special model for them, then you have to buy for the API. In many cases, companies don't sell APIs, it's just there. If you remember, a situation is similar to what we went through when web services were introduced. Remember, like 20 years ago, all these big companies with mainframes, they accumulated tons of data written in different languages, and they decided we need to find something to open up, so other people can use our financial data or telecommunication or customers or whatever we accumulate. They started to come up with an API, with a standard API, solve web service, if you remember, and then eventually they were replaced with REST. But the point is, when this little thing comes out, the API is somewhere there as well. So in that regard, our life is a bit easier. So the other thing that is interesting, these devices are wearable but on skin. So nobody is surprised, of course, to see this Fitbit thing that counts your steps. I had 2 of them. I lost one. The other one was eaten by my dog. But this is something that you cannot lose. I mean, it's like a tattoo on your arm or any other part of the body. So it is moving there. Commercial devices are using it everywhere. Pirelli, if you know these tires by Pirelli, they put these sensors in the tire to check on the temperature in the tire, if it's worn out or no. Irrigation system, of course, house automation, agriculture, they check all devices, they check the soil and everything. Everywhere, all these sensors are there. So it is a big deal. It is in the industry. So we want to be there as well. Anybody saw that movie, The Birdman? A thing is a thing, not what they think about the thing. I like that quote from there, but what in our world, what is a thing? It's a thing, plus an application that comes with a thing, plus an API that you can use, plus a website that they created, the vendor, right? So this is basically a combination of these things, is a thing, in the IoT respect. A typical setup, you buy a thing and they tell you, you have a smartphone? Yes. Here's an app, install the app, and it'll count your blood pressure, like scales, for example, or what steps, how do you sleep, and everything. The point is, typically, a thing comes with an app for a smartphone or an iPad, and it comes with a device, right? Device, in some cases it talks to a thing sends a signal to the server of the vendor, and that's a typical workflow. So and the manufacturer is using any of the protocols they like, and it could be different protocols, of course. And now I can say that there are 2 groups of people. There are people who are interested in programming hardware. I know all these devices like Raspberry Pi and other toys are there. If you are the person who is interested in that, that's fine. I am not the person who is interested in learning programming of a particular protocol or a particular device. I'm not just a guy. I'm not saying it's bad in any way. I am interested in the integrating of devices that already exist. I don't want to know this protocol. I don't want to know this leg when a device talks to the vendor site. So obviously that area will be standardized as well. Eventually, sooner or later, there are also, like, for now, maybe a dozen of different standards that they are using. But again, I want to make sure that I am not looking into it. I am looking into how we can use the data that are accumulated by a device. So the low level, yes, you need to learn the protocol. The high level, you need to create your own solution and integrate the devices that you like into your own existing business workflow. In this area, high level I call it, there is no need to learn all these vendor-specific protocol. You know REST, most likely they have an API. You need to know how to authenticate. The user. So your applications that you will write can act on his behalf. This is important to understand. If I'm a user, for example, of Instagram, forget about things. If you want to write an application that will offer a better UI than the original on my behalf, right? So I need to log into Instagram. I can do it either through your application or through other authorization server, and then I can access to my account. So the point is, we have an application that you as a programmer write, and we have a user who owns some resources. In previous example, it was Instagram photos. In our case, we are trying to integrate a couple of devices, one of them being blood pressure monitor. So the person measures the blood pressure, the measurement fly to the vendor and saved somewhere in the database for the user. Of course, this is a private information, and the user doesn't want anybody to see his private medical data. But if we write an application and if the user of this device agrees that the measurement will jump right into our application, our client application, it's fine. I'll explain how this can work in the real life. In many cases, mistakes are made because people manually enter the data. It's like from last year's news that tons of errors were made during this Obamacare application. So what we want to do, we started to say, we have a process. A paramedical comes to a house of a person who wants to buy life insurance. They need to do different measurements over there, right? They need to measure the blood pressure, weight, and something else. We happen to have these devices. Anybody can buy them. They are on sale. Scales are on sale. I didn't bring them today. The blood pressure monitor is on sale. So the Wi-Fi, through the phone, it sends the measurements to the vendor. So the idea is, if I am a paramedical, I come to an applicant's house. I own the device. There's only one device. I don't expect people who applying to insurance have devices. It's only my device. I am a registered user as a paramedical. I came to a house and I am measuring the measurement. The measurement goes into my account. Of course, I will be visiting different people. It's not my measurement. I understand that. But it's under my account and under this device. I want to make this part clear. So, if I will do a couple of things while being in the house of this person, if I will measure his blood pressure, and if I'm running my application, if I will be able to write the program that will read his data from the server that stores all measurement from this device, the data can jump right into my form that I am filling out for the guy or a girl. Do you understand the idea? Measure, it'll go over the internet to their vendor server using their protocols, I don't know what. Then my application will use REST, will use OAUTH, will use for push, we'll use WebSockets, and we'll get the data into our system. So that was the idea. So we want to put a server in the middle. So we can query not the device, but the server of the vendor to produce that device. I did this presentation a couple of times before. I was using a couple of devices over there. Today I didn't bring this the scales, but I brought this device, and hopefully we'll be able to see it in action. That device is done by the Fitbit company, the same one that does all these bands, this wristbands to measure steps and everything. They also have this device. They're not expensive anymore. $100 for something, these scales. You stand on the scales, it remembers several people in the family, and it sends the signals, and it immediately recognizes that it's you, and approximate weight. And this is a blood pressure monitor from a different vendor. For us, it was important to try different vendors. So ihealthlabs.com, it's their site. We bought that device from them, and we bought that device from the other company. And then we started to look at the APIs. And by the way, let me show you the form. This is our business application. In particular, this is a medical examiner report that when the guy comes into the house, they will need to fill out this form. And in particular, that form has a couple of fields. This is weight of a person. And over there, there is a blood pressure measurement. And they have to do it 3 times and so on. So our use case or proof of concept was, can we make sure that these 2 fields are automatically populated in our application if I have this consumer device? That was the goal. Now let's talk about a typical workflow between a device and their own server. So in this case, I am showing you again, it was from Fitbit. If you would buy such a band, the wristband, there are different cases. If you have an iPhone, for example, you don't need anything else. If you want to use a computer to communicate with device, they have this, they call it dongle. So the point is, over here they use Bluetooth between their thing and your smartphone or a computer, and then somehow using, I put it XYZ protocol, the data is going to their server. So technically this is what they sell. And then you can go to a website and you can log on to your account and check your measurement and everything. This is a typical situation. Again, we don't want to know what is an XYZ, and we are not even going there. We want to add our server to be our application. So let's take a look at the communication. Let me go back. So we want to put our server somewhere in the middle. So our server, I called it my server, but this is our application where we deployed it. We deployed it on Java, and the front end for the application is we've written it in Dart language, converted into JavaScript. So our web server can do polling, or maybe it's a pops up. Now we need to read an API of that particular vendor and see how they can give us the data. For example, if I will be polling every 5 seconds, the measurement, again, given the fact that I am authorized, that I am allowed. When I say I mean the application deployed on my server. Then I'll get the data from them. In some cases, they will say, you don't need to do polling, we can give you pops up. So their API will open up some way of getting the data from the vendor server. So if we will get the data, we can push the data from our server to our client. Again, to be on the same page, our medical examiner form. Then we bought another device from a different vendor. We open up their documentation, their API, and we read it. Again, typically, they offer you REST API, and they offer you OAuth 2 for authorization, maybe OAuth 1 or OAuth 2. I'll talk about it in detail. So if we bought another device, we need to do this line for another vendor. But again, we are in the middle. We accumulate all the data and we push the data to our screen. Is this clear, this diagram? Yep.
What value proposition are you adding by adding your server? Previously also the device and the server were communicating, right? So what are you doing being in the middle?
What's the value? Why would we want to be in the middle? We want to populate our documentation. If you bought a device to measure your own, all right, so you have it, you own it, you log in, you enjoy your measurements. But this is not what we want. We want to send a person on the road that will go to each of you, will measure your, assuming that you are applying for insurance, for example, measure all the measurement, and they will automatically jump into our system, into our database, into our application. And there is no way that you will pay me a couple of bucks, so I will just put a lower measurements and so on. I mean, it depends on how much you're going to offer me, of course. So maybe I'll have some workaround. Now, how the whole thing works. I'll go through the OAUTH protocol in steps, but to start something with a vendor, you need to register with the vendor. Like in our case, we went to this iHealth Lab site and we said, we want to write an application. What do we need to do for that? And again, it's a typical situation. You need to register your application. We are writing this medical insurance application and we want to apply for an ID for the application. Again, I want to reiterate this notion that we write a program that will act on the behalf of a person, right? So we want to apply for a client ID, they call it client secret, but basically it's the same as a password. For people we say ID and a password. For the application we say client ID and the client secret. And we need to submit a redirect URL. So this is how it works. If I have a device, I need to log on to this device. Authentication works the same, right? And if I am logged on the machine, and if an application wants to get the same data, that server needs to know what is my client ID, what is the secret, and where to redirect. Again, it's going to be my website, where to redirect if the user of the device is logged in to the device, the server. So that's the idea. And I'll talk about OAuth a little bit more, but for now just remember, on my server we store the secret that was originally given to us, the client ID for our application, and eventually we're going to get authorization tokens. When we will be working with a server, we'll get the tokens. So that's a big picture. Basically, with green arrows over there, you see a typical scenario that the vendor wants, but everything else is our additions to the typical workflow. So now I'll try to do the measurement. Actually, if anybody wants to measure the pressure, do you have any volunteers? So what I will do, I can measure for free. You want it? All right, come over. So I want to show you the whole process. So basically, on the iPhone, let me give you a chair, so to make everything as close to as possible. So we are. So are you applying for life insurance by any chance? I'm not selling insurance, so no worries. I'm a programmer. So let me show you the device. So it's a regular device, right? It's a Bluetooth, right? The only thing is, for now, it's not connected. What I will try to do, I will try to connect it to my phone. So if there is no our application at all, it still will work. What's your name? Jacob. So Jacob would be using only these two. Do you have iPhone 6 Plus? Okay, Android maybe work as well. So what I will do, by the way, do you guys know how to, I recently learned something, how to show the screen of my iPhone over there. QuickTime. You go to QuickTime, which is installed over there, file, record the movie, and my phone is connected, so you see over there, it's my iPhone now. So check it out. BP5, that's a device. This is a device. It is connected using Bluetooth now. So let's try it. This one. So even I can do this. But before we will do any of these, I want to start my application. A simple one that we create. So first of all, we need to authorize a device. Do we have connection over here? Authorize iHealth. iHealth is this device that we see now. I am the owner of this device, of course, so I know the user ID and password. Please pay attention. Authentication part is being done now. Authentication. A user of the device is supposed to sign in. I signed in successfully to the vendor site over the internet, so this device is authorized. All right. And this is our application. This is not theirs, it's ours. So what I want to do, of course, I will not be entering last name and first name. I will say I want to do automatic from which device. This is an application for a demo which uses this device and the scales. Again, I don't have the scales. So right now we are ready, right? So what I will do now, you relax, no worries. So I'm starting the applications that came with this device. I press the button, you see it over there, right? I press the button start. Do you see it or you don't see it? You don't see the whole picture. See, it goes. So at this point, the measurements are being done, and when it's done, the signal, the measurement, will go to the vendor server. This is a typical scenario without us in the middle. But the point is, if everything works fine, I want to see in that field waiting for data on the screen. I want to see the measurements that will come. All right, so that's your thing. No worries about this 101. I'm telling you, I thought that there was something wrong with this presentation mode. I did this presentation several times. Whenever I am on stage, if I show it on myself, my pressure goes up. Really, I don't know. So basically, hopefully, like maybe in 30 seconds, our application is paused. Yeah, see that? Thank you very much. You're gonna get a book as a souvenir for all your suffering. One second, I'll give it to you now. That's our last year's book about web development enterprise. Enjoy. All right, so you saw the whole process, right? And now I will explain you obviously what's under the hood, but the point is I integrated this device into my application. So the scales is a different box and a different vendor, of course. Alrighty, so now let's go back to slides, to the boring part. This part is done. Now I'll explain how it works. So these are the players that we used in this application. I will not go over each of them, but RESTful Web Services, standard. OAUTH Syndication and Authorization. We use this OAuth2 protocol. Actually, with scales, they don't support OAuth2. They support OAuth1, but it's still the same protocol. WebSocket protocol we used to push the data between our server and our client. So on the back, there is polling between vendors and our server, and as soon as we get the data, we push them to the cloud. Front-end development was done using the language called Dart. Dart is a language by Google. For now, it's more productive way to write JavaScript. I can put it this way. I don't think this language will be around 2-3 years from now, because ECMAScript is coming out, and you will be able to do everything in ECMAScript 6. JavaScript 6. But for now, for this year, for next year, we couldn't find anything more productive than Google Dart. Nice system, nice ecosystem, nice language, very close to Java, very easy to learn for Java developer, generates everything. So we use that. JSON for the data communication, data exchange. Backend was deployed using Spring Boot with embedded Tomcat, and Gradle for build automation. But let's talk about the top ones. The top ones. So REST API. I don't know. I'm planning to spend maybe 5-7 minutes. I assume that maybe most of you know what is REST, but I still will, like a quick tutorial. REST is a representational state of transfer, and these are the principles on REST, right? So every resource has to have a unique web ID, a unique ID on the web. All access using REST protocol is done only using standard HTTP operations, word, get, post, put, delete, like there's head, there's a couple of more, but it's all standard. Resource may have multiple representations. All requests are stateless. You can link resources, and resources will be cacheable, and the rest should be layered. I'm running fast. If you want, I'm teaching a class which lasts probably 2 hours just on REST. I don't think you need it, right? So typically we use REST API for the standard CRUD operation: create, retrieve, update, delete. Right? If in the past we were using just get and post, which was absolutely wrong, now we are using different operations depending on what we want to do. Each of these operations has different characteristics, and I do it real quick. So we use get with REST services whenever you want to receive something from the server. It's like read or retrieve. This operation has the characteristics such as safe, idempotent, and cacheable. Safe is understandable. You cannot hurt the server no matter how many times you run get. Idempotent means, it's a term that means no matter how many times you run this particular operation, it'll always return the same results. So we can say get is idempotent. If I want to get an ID, a resource, say with my resume, with this ID, it's only resume, no matter how many times you will do this, right? Cacheable is clear, so the browser can cache. Put is used for updates, existing resources. So if you want to update something, we use put request. So it's idempotent. No matter how many times, say, a person got married and she changed her last name, no matter how many times you will update the last name for the person with this ID, I mean, you will not do any damage. Delete is idempotent. If you want to delete a resource with primary key 1, 2, 3, 4, no matter how many times you will delete it, it'll do it only once. And post we use for creating new records. Post is none of the above. If you will keep adding rows to the database or creating new objects, it may create new rows, multiple rows. So there are different APIs that we are using. If you are a Java EE7 developer, it's a very simple, very easy API, very easy. So it's a POJA. You just put several annotations on top of a class, and this is how the REST routing is done. I'll show you maybe a couple of annotations over here. So the way it works, if you want to have a plain old Java object on the server and you want to turn it into a REST endpoint, REST service endpoint, the only thing you need to do, you need to add a couple of annotations. One of them is actually application path is for replacing any XML configuration. Your application, a small file like 3-4 lines, small Java class will be marked as an application. And the whole idea is when you make a request using a URL, your URL consists of several parts, right? HTTP, port, / and then the word. So whatever the word is there, you put in the small class with an application path annotation. So whenever your Java server will receive a request that contains this particular fragment, it'll understand, oh, it needs to be routed to this REST service. Then the REST service may have multiple Java classes, right? So okay, for example, it was insurance over here, or IoT, the word. Now after that, what do we want to do? The next keyword, and the next word that is specific to your domain, to your application. So then the path annotation. All right, so that class was marked with an annotation, blood pressure. All right, so that's probably an endpoint for processing all requests for measuring blood pressure, and so on. Different annotations. Then you will mark specific methods inside the class as a get, as a post, as a put, as a delete. So this is how Java server will route the request and wind up in a particular method of that request. The web service can produce some data and consume some data. Typically we produce JSON, so you can mark a method and specify a MIME time like application JSON, so we produce JSON. So I will not be going into details. I'm sure that most of you know how this works. For example, up on top, 2 lines. Basically, no, there's one line that is missing in the middle. So you need to write a class that extends the application in Java E7. And then a sample blood pressure service, REST service, right? So you add a fragment iHealth in this case. So if the URL will have the server name port / IoT demo / iHealth / BP, then the request will wind up in this method. See, if it was get request, for example, and it was marked with BP, and we had this pattern in the URL, so we will be here. So over here we'll do some. This is a place where we will be polling that vendor's server. Give me the data. Give me the data. Give me the data. When the data is there, we will produce application JSON, and our server will get it. In Spring, it's pretty similar. In this case, we've been using Spring Framework, but it's pretty similar. So you create a class, you annotate it with REST controller, REST mapping iHealth, then you annotate some method to process GET requests, and if the URL has BP, the rest is the same. So very similar and pretty simple these days. And now let's talk about authentication, OAUTH. Basically, I'm sure each of you already used OAUTH authentication, even if you didn't know what it is. I'm sure many of you try to log into some application and there's a button next to it saying, do you want to log in with your Facebook ID or Google Plus or LinkedIn, right? So what does it mean? This is what it is. They want to authorize you. They want to use your ID on one of these services, Facebook, LinkedIn, or whatever else. And what do they use in there? They use something that is called Authorization server. You can imagine that Facebook has 1 billion or more account, and they take security pretty seriously. And LinkedIn has, and Twitter has, so multiple large social media servers offer you this service. Before we continue, just to make sure that we are clear on the terms, authentication means that you are who you say you are. If you are saying that you are Jay Smith, then you are Jay Smith, and you know the password. Authorization means what you can do. Yes, we know that you are Jay Smith, but maybe you cannot update the data. Maybe you cannot post likes or write on my wall, right? So, in OAUTH, there are these players. There is a server with resources, for example, your applications that you like, which has a button. Do you want to log on with Facebook? If you will say yes, it means that you want to use Facebook to authorize you with this application. Again, you're connecting to application A, but Facebook will authorize you. How this can work in general? There should be an agreement between your applications that you wrote and Facebook that we want to use their authorization server. Or, if you're a big company, as a matter of fact, vendors of these devices, they have their own authorization servers. So, for example, they don't forward me to Facebook. They have their own server and they have their own rules. And we have a client, the third player. The client is my application. So we have a user who physically will enter the ID and password somewhere. We have an authorization server. It could be our company server, vendor server, and we have a client application. In my case, if you remember the demo that I just did, I started to log on to the account that was registered with this device, with iHealth Labs. Authorization server is also at their premises. It's their authorization servers. I didn't use any Facebook or anything. And the client application is the one that we wrote. It's on the server and this simple web UI that you saw. Do you have questions about this part? No? So, a typical situation. Maybe not a typical, but you've seen this screen many times, right? So the application is a client application. All these buttons, now we can say they are 4 different OAuth servers, authorization servers, and you can use one of them. Now, how these servers work? Whenever you will read a tutorial on OAuth services, they will often use the analogy with the valet parking, especially if you have a more or less fancy car. The key contains a little key that you can pull out for the valet, and you can lock the glove compartment with your diamond in there while you are eating at a nice restaurant, right? So the person from a valet can park the car, but he cannot open that thing. So what do you technically give? You give a restricted access to your resource being a car in this case, right? So that person can do something, but not everything. Similarly, when you are saying that I want to use Facebook for authorization, it doesn't mean that my application will start with all these likes and posts and everything all of a sudden. Typically, when you see a screen, when you agree on authorization, like in this screen, for example, this is Candy Crush, if anybody doesn't know. If I wanted to go from Facebook and play Candy Crush in there, they say, do you want to use Facebook for authorization? Yes. And then it says at the bottom, actually at the top, it says that the Candy Crush Saga, the game, will get access to your public information on the Facebook. But at the bottom it says that this doesn't let the application post to Facebook. So at least you can be sure that they will not be doing any surprises with your account. So restricted access you give. So what is a restricted access? Again, coming back to the analogy with the car, with the valet parking. You give a little key to that guy in the valet parking. That little key is basically analogy of authorization token. In OAuth 2 that we use, there is something called authorization token. It's an encoded in a special way string. It's a long sequence of characters that provide an access. Not full access, but restricted access. To whom? To the application that acts on the behalf of the user. And how the whole thing works, I'll explain you now in detail because it's important. So how this works? Again, all the steps, now you remember the demo, so you can relate to it easier. My company registered an application with a vendor. In this case, iHealth Lab that produced that device. For that, we received a client ID for the application, the secret, and it's a must. The redirect URI is a must. So we must provide where to redirect if the user will log in successfully. Then my company built an application, like that simple screen. So authorized device, wait for the measurements and everything. Then the user, again, if you remember the demo, I just did all that in front of you. Then the user opens up my app and logs into the things vendor using it was a standard login window. So far, so good. So far, no OAuth in the picture yet. So far, I made sure that a resource owner, the user who owns the data, the measurement, logged into the site. If I wouldn't be logged into the site, they will say, please log in first and then we can continue. So that part is authentication. It's done absolutely separately. Now, my app generates this, the HTTP request that can look like this. I want to remind you that the demo that I showed you was using this application that was deployed on the server. Nothing was on the client in terms of all these secrets. But OAuth 2 allows you to get access to from the client only as well. It is considered less secure. But we don't use it. So we use it from the server. So our server connects to this device's authorization server. Client ID, I put 123, that's the one that was given for our application forever. Redirect URI, the one that we got approved by the vendor. And then we said response type equal code. Response time equal code. It means it's the first communication between our application and the authorization server. We say, we are planning to get a token from you, but it's not a token yet. Please, can you give us a code so we can make another request for a token? This is what it means. Then scope. If you remember, authorization means what you can do. Post on the wall, put likes, delete images. I'm using the social media because it's easy to relate. So if the server, the authorization server of this vendor gives you different features that you can do with the measurement, then you will specify them as a string, space separated. And final thing is optional state. I'll explain you why it may be needed to prevent a specific attack. But for now, just remember that I can generate a state. You can generate a state based on the session ID. Your application runs on some server, and if a user, if I logged on to the application, I have my own session, so based on the session I can generate an ID. And I will attach it as a state to the end of the URL, and it'll go to the vendor. The vendor will just return it to me as is. The vendor will not touch state, and I'll explain you why. But for now, just remember that it will not touch. So if everything is fine, the vendor sends me a redirect with the code. The vendor gives me the code, and again, state is attached just for security purposes, unchanged, and I do another request. Now I put inside that URL the client ID that was given to me, to my application, the secret that was given to my application, right? The code that I just received in the previous state, redirect URI is the same, and grant type authorization code, which means I want a token from you. Give me please authorization token. And this is when I'm going to get it. And this is that valet key with restricted capabilities. From now on, I will be able to take this token. I will get this token, authorization token, and I can keep it in the session. I can attach it to the URL. I can put it in the header of the request. That's my token. The token can be given for me for a long time, or it can expire. Again, it depends on the device and scenario. It can be given to me for 10 minutes or 3 minutes. And if it'll expire, there is something else called a refresh token. But in some cases, it can be given for you forever, but you serve it on your server somewhere, and you keep reusing it. But most likely, it'll be timed out. So what it gives you, this token? It gives you the chance to not be running authorization each time over and over again. You got it. You went through all that already. And the only thing that I had to enter was authentication in the beginning, if you remember, with a vendor. And then people are using my application, and this token goes back and forth between our server and the vendor server. Yeah.
Is that token stored in the browser?
In our scenario, no. In our scenario, we don't go to the front end at all. All this is stored on our server that we wrote and deployed. But they have a way to keep it on the front end only, JavaScript only, talking to them. But this is considered to be more safe. So this is basically the process with this I have. I request, I'm a resource owner, I own this device. I say, give me the grant for authorization, that code. All right, you got it. Give me the access token. I got it. And now I keep sending it back and forth. If the token was with expiration date inside, it'll expire, say, in 10 minutes. But when I get the token, I may get another thing that is called refresh token. And if the time expires, 10 minutes is up, and that token is not working anymore, then I can make another request giving a refresh token again to the server, saying, all right, this is a refresh token, please take a look at it. It's mine, yep. So give me a new one, new authorization token, and I will get a new one. So that's how it works. Finally, I want to go back now and explain you the scenario why you might need to do to have state. If it goes back and forth, you generated the state based on the session ID. You send it to the authorization server. and they just bounce it back to you. There is a scenario that is called cross-site script forgery. No, cross-site redirect forgery. Yeah, CSRF. Right, so what it means, if I'm a bad guy, I can log into the application. I will receive a token, and then I will call Mary, who happened to be logged in to the same vendor. And I say, and I'm sending her a link saying, Mary, can you please use my link? And Mary is using my link. She is logged in over there, but I have the URL that was given to me, to my application. So if that's the case, if I'm using this state value, in this case, it won't work, because Mary will get into my server will get Mary's session, and maybe generate an ID based on that session, and it will not be the same as this bad guy sent her. So that's the only thing. If you are not afraid of this kind of scenario, you don't even need to attach this state at the end. So this is how it basically works. And finally, we are pretty close to the end. I'll just, again, it's up to you. Do you want me to spend 5 minutes on WebSockets, or you're tired enough? Enough? Enough is enough, right? All right, so just then 1 minute. It's super crash course on WebSockets. We used to do AJAX, long polling. The HTTP protocol is super duper heavy. If I need 10 bytes, a string of 10 bytes, it'll add 200-300 on the request and 200-300 on the way back. With WebSockets, it doesn't happen. The other thing is, when you do HTTP requests, all these AJAX, whatever, it's only one-way street, right? I make a request, I get a response. It's either there or back. With WebSocket, it's full duplex, so the data goes back at the same time, and they are really, really small. So, and also, this is an example. You can see the sizes. Just to get this little, it's a stock quote of the situation. When you see this little number changes, you can see how many bytes over there. How many bytes goes back and forth with every little digit change. 100. So basically, we switch to WebSockets whenever we can. And the other good thing is that the server can push the data to you without any further requests. So we are using the WebSockets. WebSockets is a standard supported by Java EE 7, starting from specification 7. Very easy to do. And here here's an example in JavaScript, for example, which you would write. When you establish connection with WebSocket, it immediately upgrades the protocol. If it happened, there is no HTTP anymore. After that, done. Only upgrade request. After that, when you get a message, you get a call back on message, on error, on this, on that. And a very similar situation is in Java EE 7. In Java EE 7, you can annotate all your methods. It's a POJA. And on open, on method, on message, call this, on error, call that method. Server input, very easy. Or the other way, you can extend class. With that, here's an example, and this is an example without any requests. I just wrote a little program without any request. You start the application on the server, and it just sends the text. It pushes to whoever connects to the server. So no request response, just a duplex thing. You had a question?
Yeah. So with WebSockets, you can still build a payload solution if the server goes down and if you are running multiple servers.
Right, of course. When you try to make a push, if you didn't go through, you get an error. On error, you wrote a method what to do with an error. Maybe you'll do a retry logic, or maybe you will save the data. Yes. And Spring also supports it, and it's an example in Spring. I'm not going to do that. Spring Boot is a nice way to deploy the application. You have, in our case, we had an embedded Tomcat. It's nicely packaged in one jar, so you can run it from any command line. We use Gradle script, build a jar. Jar has inside a Tomcat. If you don't want Tomcat, put another source container in there. So this is pretty much it, I believe. Oh yes, one more thing. there was a big deal like a couple of years ago. BMW is using also these tons of sensors in there, and they have something called connected drive. And this is something that you can use the internet, you can open up your car remotely. So like, obviously, if there is a security, there are people who want to break it, right? So somebody figure out a way to open like 2 million cars from BMW. So I'm not sure until they will fix it. Maybe you should be buying a simple Mercedes or something. All right, that's all, guys, for today. This is my contact information. This is the book that you just saw. It's from last year. This summer, Java for Kids. If you have kids, teach your kids Java. No Starch Press will publish this book, and all the drafts are available for free, by the way, now. Just do easy, quickly, Java for Kids in my name. You will see it's on GitHub. And this is the second edition of my Java programming book that will be released soon. Thank you very much.